Hey, let's talk about capacitors in parallel. Remember, capacitors store electric charge. And I don't know if I said it before, but let's just remember that capacitors are opposite of resistors. So everything you remember about resistors, capacitors do the exact opposite. In this case, the same thing. Again, capacitors store electricity, store electric charge. Resistors use electric charge, so they behave exactly opposites. So if I have two capacitors hooked up, what I'm going to have here is a positive input wire and a negative output wire. Now, since each side of that capacitor can get back to the battery, each capacitor has the same voltage, so same V. And that's kind of the key thing to do it. Now, they have the same V. What I want to do, though, is calculate the equivalent resistance, the equivalent capacitance. What happens when you put the two capacitors together? Well, remember, C is equal to Q divided by V. So if I want C total, I want Q total over V total. And that makes sense. Now, since there's two capacitors, what's going to happen is the charge is going to separate the same way the current separated before in a parallel circuit. In a parallel circuit with capacitors, it's the charge that's going to separate. So I can say C total, or C equivalent, I can say it either way, is equal to Q1 plus Q2 divided by V. And so what I simply say is the total charge coming out of the battery gets split between the two capacitors. So I can rewrite that if you want, Q1 over V plus Q2 over V. Wow. But I know V's are the same. Oh, that's beautiful. So if C total is equal to Q1 over V plus Q2 over V, wait a second, Q over V, that would be C2. Q1 over V would be C1. So therefore C total is equal to C1 plus C2. Just add them up. Now remember, that's the exact opposite of what we do with resistors. Resistors in parallel, we have to add the reciprocals of it. I hope this helped. We'll do some more practice in class.